this before, but just to make sure we're clear on this, because I think it helps to make connections between things. We started with equations you didn't need any new stuff for. Exponential equations where the bases were related. Then we needed to learn some logarithms before we could do this. So we took some time out and learned something about logarithms. And then once we learned something about logarithms, we could solve that type of equation. We could also look at logarithmic equations. So all of that solving stuff. And then we just looked at change of base rule as related to solving equations. We're going to look at graphing stuff now. Okay, graphs of each of those types of functions, exponential and logarithmic functions. Looking at them as functions. Over the course of your math learning over the years, that's usually how things work. In grade 8 or even earlier than that, grade 7, whatever, you learn how to solve, say, linear equations. 3x plus 2 equals 10. That's a linear equation. And then later on, grade 10, you look at, hey, well, why don't we look at what y equals 3x plus 2 looks like as a graph? Look at all the different values, and then we'll see. So first you learn about how to solve the equations, and then you look at them as functions. So it's the same thing here, right? With quadratics in grade 10 and 11, you start to look at them as equations, and then later look at them as graphs. So you learned how to solve these equations. But we're gonna look at what do the graphs of these functions look like. So solving what we did earlier, 3x equals 7. Now we're going to look at, well, what does the graph of y equals 3x? What does the graph of that look like? Not finding one specific value here, but drawing a graph. And then the last things we will look at, I guess I need more highlighters, don't I? How about this funky looking color? For applications of things. Okay, there's applications of exponents and logarithms. And then the last thing's kind of unrelated. Actually, I need a worse color here, like that. Can't even see it, but one extra thing at the bottom there. I think it helps if you have those connections in, we're doing a bunch of equation solving, we're doing some graphing. Rather than try to learn them all as individual things, I think that's going to help you somewhat. The way that this 2.7 is set up, it's set up where it's quite investigative. You do some of the learning, sort of more discovery type learning, rather than me showing you right away all the concepts, because I think you can take this and just make a table, see what the graph looks like, make another, a graph for a different function, and start to look at and discover some of the ideas. This would be the same as, say, in grade 10, when you learn to graph things like this, 3x, y equals 2x, y equals 1x, and so on, right? Y equals a half x. When you graph lines in grade 10, like now you probably know what that number means, right? What that number does. That number in front of the x, what does it change about the graph of that line? What does it change? Number in front? The slope, right? So 3x is going to be maybe like that, 2x is going to be there, 1x is going to be there, or something, and half x. It changes that, and that's the goal you're looking at. But to start it off, probably somebody said, make a table and graph that, make a table and graph that, and so on, and then tell me what that number does. It's the same thing here. You're going to be looking at what is this, how does changing the base of the function you're looking at affect the shape of the graph that results? So at first you're doing it by table of values, but then we're going to try and go beyond that. I would say don't necessarily fill out this table from left to right. Start with the easier values to sub in like those. Y equals 2 to the x. You can put in a 4 and a 3 and a 2 and a 1, and then you have to think about, I would rather you did this without a calculator, because it's going to be better if you come up with these as fractions over here rather than decimals. It's going to have more meaning to it, I think, if you do that. Remember that negative exponents just mean reciprocals. All right, so if you have 2 to the negative 5, what's that the same as? Negative exponent just means 1 over that, right? Reciprocal of that, 1 over 32. So you need that for that concept. You need it back before you do this. You're graphing this function by looking at some specific points and then drawing a nice smooth curve through them. Think about the shape of the graph. You probably have to do the first 2 graphs and then you can answer some of the questions. This is if you have a number smaller than 1, right? If the base is a half, base is 1/2. The first one, the base is 2. I'm asking you things like asymptote. You're going to have to try and discuss that with the person next to you. Remember what that means. Again, I'm not going to fill all these in first because it's better if you work through, do some of it on your own first. Then you can start to maybe summarize it or do it in more general terms, like how does the shape of this affect it? You can take your calculator and just try a bunch of different things. Y equals 2 to the x, y equals 3 to the x, 5 to the x, 0.2 to the x. Just try a bunch of stuff and think about it, okay? And then the goal is describing in the end how does changing that base affect the shape of the graph. Notice things along the way as you go, okay? Can you get going on that? I'm going to circulate around and check in with each of you to make sure you understand as you're working through this, and then we'll see where we are, okay? Can you get going on that, please?